Hello friends, moving to the next lecture of second unit, that is baseband digital transmission. Last lecture we have seen that what is multiplexing, what is the need of multiplexing. Then we have seen that what are the different types of multiplexing, and that we have seen analog multiplexing and digital multiplexing. In analog multiplexing, again there were two types, that is frequency division multiplexing and wavelength division multiplexing. In digital multiplexing, we have seen time division multiplexing. So we have seen what are the advantages, what are the disadvantages, how they are going to work. After that, we have seen digital multiplexers. Then we have seen the short concept of what is crosstalk. So now moving towards our today's lecture, today we are going to cover topics that what are line codes, what are the properties, characteristics of line codes, and one by one we are going to see the each type of line codes. Now, starting with our today's lecture, that is conversion of data. The communication that occurs in our day-to-day life, it is in the form of a signals. So it may happen that signal, it could be in the form of analog or it could be in the form of digital. Now, suppose you have analog data or you have digital data and you want to establish a successful communication over a distance, then there may be requirement of converting those data. So it could be analog to analog conversion, it is there, it could be analog to digital, digital to analog, or digital to digital. So moving towards this point, analog data are a function of time and occupy a limited frequency spectrum. Such data, it can be represented by an electromagnetic signal occupying the same spectrum. Similarly, digital data, it can be represented by digital signals with a different voltage level for each of the two binary digits. But these are not only the possibilities that we required only analog to analog conversion or we required only digital to digital conversion. There are more possibilities, as like your digital data can also be represented by analog signals by use of your modem, that is modulator and demodulator. After that, similarly, analog data, it can also be represented by digital signals, and the device that perform this functions for voice data, it is called as what? Codec. Codec, it means it is a coder as well as decoder. So the conversion, it is of how many types? The conversion, first it is of analog to digital conversion, it is there, then digital to analog conversion, it could be analog to analog conversion, and last it could be digital to digital conversion. So in this lecture, we are going to focus on what? Digital to digital conversion. Now, the representation of digital data by using digital signals, it is nothing but your digital to digital conversion. So what are the techniques that we are going to use? So it could be line coding, it could be block coding, or it could be scrambling. For this lecture, we are focusing on what? Line coding. Now, from on the screen that there is a figure that this is a sender. It has on that computer, it has a data in the form of your digital form, that is in the form of 0, 1. So if this sender wants to send this information to this your receiver, then it needs to convert that digital data into this digital signals by means of this encoder. And at the receiver, this decoder, it is going to convert this digital signal, again revert back to this digital data. So at sender side, digital data are encoded into a digital signal, that is encoding of digital data into digital signal. Whereas at the receiver, the digital data are recreated by decoding the digital signal. Data stored in the computer is in the form of zeros and ones. So to be carried from one place to other, the data is usually converted into what? Digital signal, and this is called digital to digital conversion, or it is also called as encoding digital data into digital signals. Now, what are line codes? There are different ways of defining these line codes. So we can see that one. That first one is digital output of the PCM coder is converted to an appropriate waveform for the transmission over channel is called line coding, or it is called what? Transmission coding. In another way, we can define it that a line code is the code that is used for data transmission of a digital signal over a transmission line. And the process of coding is chosen so as to avoid overlap and distortion of the signal, such as inter-symbol interference. In another way, we can tell that binary ones and zeros, such as in PCM signal, may be represented in various serial bit signaling formats called line codes. Now, moving towards the properties of line codes. The transmission bandwidth for a line code, the transmission bandwidth, it must be as small as possible. About a power efficiency, for a given bandwidth, the power, it should be efficiently used. It means the transmitted power should be as small as possible. The timing content, it should be adequate. It means it must be able to extract timing or clock information from the signal. Next property is that long strings of ones and zeros, it should be avoided in order to maintain transparency. Otherwise, what is going to be happen? If continuous ones or zero it is there, then there would be a DC component which is going to distort your signal. So we couldn't pass that DC component. So that's why this long strings or continuous of ones and zeros, it should be avoided. Then it must detect and preferably it correct detection errors. For example, in bipolar case, a signal will cause a bipolar violation, and thus it can be easily detected, due to which the probability of an error is much reduced. In just few minutes, we are going to see that what is a bipolar case. Now, moving towards the characteristic of line codes. First, there should be self-synchronizing. It means both the receiver and the sender clock, it should be synchronized. Otherwise, the sender, what the data it has been transmitted, the receiver, it is going to interpret the data in a wrong manner. There should have some error detecting capability. Then there should be immunity to noise and interferences. It should be less complex, and there should be no low frequency component called a DC component, as long as distance transfer is not feasible for low frequency component signal. And there should be less baseline wandering. Now, we are going to see that what are the different types of line coding. So, line coding, basically it is divided into 5 parts. That is your unipolar, it is a polar, then bipolar, multi-level, and it is a multi-transition. So basically in our syllabus, we are going to focus on this unipolar, polar and bipolar. So first, moving to this unipolar scheme. In unipolar scheme, there is a type called a NRZ, that is non-return to zero. Non-return to zero in the sense what? There is no return in the middle. So you can see a figure on the screen that it is a unipolar coding scheme in which the positive voltage defines what? Bit 1, and the voltage defines what? Bit 0. It means the 0 voltage, it is going to define what? Bit 0. Signal, it doesn't return to 0 at the middle of this bit. That's why it is called what? Non-return to 0. So the data over here, it is a 1, 0, double 1 and 0. So you can see it that the entire duration, it is total duration, it is of t. So this bit 1, it is represented by this positive voltage for the duration of t. Whereas 0 voltage, it means we are not going to show any voltage to transmit this bit 0. Again for bit 1, there is a positive voltage for the duration of t. Again another bit is also 1. So therefore again there is a positive voltage for this one, and for bit 0, since it is represented what? By 0 voltage. So it is about what? Non-return to 0. But this scheme, it uses a more power because each bit it is of duration of full duration, that is of t. So it uses a more power as compared to polar scheme to send one bit per unit line resistance. Moreover, for continuous set of zeros or ones, there will be self synchronization and baseline wandering problem. Now, moving towards the unipolar scheme, that is return to 0. We have seen non-return to 0. Now, in return to 0, basically it is a coding scheme in which the positive voltage, it defines bit 1, and the 0 voltage, it is going to define bit 0. But the signal, it doesn't return to 0 at the middle of the bit, it is called it means the signal, it does return to this 0 at the middle of the bit for a duration of what? T by 2 second. See, this is your T by 2 second. So what is going to be happen, since bit 1 is represented by this positive voltage and bit 0 is represented by no voltage, but since it is a return to 0 in the sense it is going to return to 0 at the middle of the bit for a duration of t by 2. Suppose this is a duration t and this is a duration what? Then t by 2. So it is called what? Return to 0. Next, moving to the next coding, that is called a polar schemes. The polar schemes in which it has a NRZL and it has NRZI. So these are somewhat similar to unipolar NRZ scheme, but here we use two levels of amplitude, that is a voltage. Now, for NRZL, it represents level. The level of the voltage, it determines the value of the bit. So typically binary 1, it maps to logical level high, and binary 0, it maps to logical level, it is 0. So you can see on this screen that bit 0, it is going to represented by this what? Negative voltage, and whereas bit 1, it is represented by what? Positive voltage. So again, next string, it is bit is 0, so again it is moves a transition and it has a negative voltage 0. Then after that 1, it is going to be what? Positive voltage, again negative voltage, and continuous 1 it is there, so 1 it is represented by what? Positive voltage. After that double 0 it is there, then it is represented by what? Negative voltage. So it is about NRZ. NRZ in the sense non-return to 0. It doesn't come to the 0 at the middle of the bit. Now moving towards the next type in polar scheme, it is called NRZI. That is NRZI stand for what? Invert. Now the two level signal that has a transition at the boundary, if next bit that we are going to transmit is what? Logical 1, and it doesn't have a transition if the next bit that we are going to transmit is logical 0. So you can see on the screen that what it tell, that if the next bit that we are going to transmit is logical 1, then there is a transition. So suppose we are assuming that initially it is going to start your voltage level, it is going to start at the negative voltage, and first bit it is 1. So if it is going to find the next bit it is a 1, then it is going to make what? Transition. So it is going to make transition, and it doesn't have a transition if the next bit that we are going to transmit it is a 0. So next bit it is what? It is a 0. So if it is 0, it doesn't make any transition. But again, next bit it is what? 1. So if next bit it is 1, according to this one, that what it should do? It should have a transition. So see, there is a transition. But next bit it is what? 0. But if it is 0 it is there, then no transition over there it is there. Again next bit it is what? It is 1. So if it is 1, that is what is going to be happen? It is going to make what? Transition. Again there is a bit, there is a transition, bit 1 it is there, then again it is, there is a transition, but next bit it is 0, so no transition it is there. Again, since next bit it is 0, so no transition it is there, but last bit it is 1. So if it is 1, it is going to make a transition. So in polar schemes, what is going to be happen? We are going to use what? Two voltages, that is positive voltage and negative voltage. Now moving towards the disadvantages of it. The problem with NRZ is that the receiver, it can't conclude when a bit ended and when the next bit it is started, in case when sender and receiver clocks are not synchronized. Next type of polar scheme, it is what? Return to 0, that is RZ. Now, the one solution to your NRZ problem, it is what? RZ scheme, which uses three values, positive, negative and 0. So in this scheme, what is going to be happen, that signal goes to 0 in middle of the each bit, and the positive voltage to represent 1, negative voltage to represent 0, and 0 voltage for none. So this is a figure. The logic that we are going to use is to represent the data that for bit 1, half of the signal it is represented by what? Plus V volt, and half by 0 voltage. Similarly, for 0 bit, half of the signal it is represented by what? Minus V volt, and half by 0 voltage. So suppose there is a data 0, 1, 0, 1, then how it would be? So suppose the voltage, it is what? Minus V volt. Since 0, it is represented by minus V volt for half of the duration, and the next duration half, it is going to be what? 0. Since now the next bit it is 1, so as you know that bit 1, it is represented by half of the signal by plus volt and half by 0 voltage. Similarly, next bit it is 0, and what we know that 0 is represented by minus V volt and half by 0 voltage. Again, bit 1 it is there, so half of the voltage it is represented by plus V volt, and next half duration is represented by 0 voltage. Last bit, it is also a bit 1, so it is represented by plus V volt for half of the duration, and the next duration it is represented by 0 volt. Now what are the disadvantages of RZ coding? Main disadvantage of RZ encoding, that is it requires a greater bandwidth. Another problem, it is the complexity, because it is going to use the 3 levels of voltage, positive, negative as well as 0. So as a result of all these deficiency, this scheme, it is not being used today. Instead, it has been replaced by better performing Manchester and differential Manchester scheme. Now in polar scheme, the third type, it is called a biphase. There is a type called a Manchester coding. It is somewhat combination of the RZ, that is a transition at the middle of the bit, and NRZ L schemes. The duration of the bit is divided into what? 2 halves, and the voltage remains at one level during the first half and moves to the other level in the second half, and the transition at the middle of the bit, it provides synchronization. So this is the figure that you can see it. The logic that we are using here to represent the data using Manchester is that for bit 1, there is a transition from what? Minus V volt to plus V volt, that is in the middle of the bit. Whereas for bit 0, there is a transition from plus V volt to minus V volt in the middle of the bit. So you can see on the screen that 0, it is represented by plus V volt to minus V volt at this middle of the bit, and similarly for bit 1 is represented by a transition from minus V volt to plus V volt in the middle of this bit. So according to this, next bit it is what? 0, and 0 it is represented by plus V to minus V. Again next bit it is 0, so 0 is represented by plus V to minus V, and but now next bit it is a 1, So bit 1 it is going to represented by minus V2 plus V. Last bit it is also 1. So there is a transition from minus V volt to plus V volt. So hope so you understood this Manchester encoding. Now there is another one that is called what? Differential Manchester. It is somewhat combination of the RZ and NRZ I scheme, that is inversion. So there is always a transition at the middle of the bit, but the bit values are determined at the beginning of the bit. So if the next bit is 0, then there is a transition, and if the next bit is 1, there is no transition. So you can see on this figure that now we are assuming that in the example previous signal before starting of data, this 0 1 0 0 1 1, it was what? Positive. So therefore there is a transition at the beginning, and the first bit 0 in current data set it is there. So it is starting from what? Minus V volt, because we have assumed that earlier it was what? Positive. So next bit it is a 0, so there is a transition. So now you can see that 0 it is represented by what? Minus V2 plus V volt. But there is a bit 1, next bit 1 it is there. So if next bit 1 it is there, there would be no transition. See, it is represented by this white circle. Since it is 1, it is going to represented by what? Plus V2 minus V. But next bit over here it is what? Bit 0. Since it is bit 0, then there should be inversion. Inversion of what? Since it was a negative, so it would be inverted. It would go to positive and it would come to this negative. Again bit 0 it is there, so there is a inversion. Inversion, so it is minus V, it is going to make a transition to this plus V volt and returning to this minus V volt. But over here, since this is a bit 1, so it is not going to make a transition directly from minus V to V. Since it is 1, there would be no transition. So minus V volt it is carried by the same for the half of the duration, that is minus V volt, and after this half of the duration it would make a transition to 1. Now since it becomes a plus V volt and next bit it is a 1, it is not going to make any transition, so it is going to carry the same plus V volt over here also, and next half of the duration it would come to what? Minus V volt. So hope so you understood the difference between this Manchester and differential Manchester. So you can compare both. See how the Manchester it is going to work and how the differential Manchester it is there. You can see that 0 it is, see, represented by what? Plus V volt to minus V volt. 1 is represented by a transition from minus V volt to plus V volt, and so on. But differential Manchester, you can see that for 0 there is a transition. We are assuming earlier it was what? Positive. Since next bit it is a 0, it is going to make a transition minus V volt to plus V volt. But next bit over it is a 1, so it is not going to make any transition. So it is carry forwarding the same, that is plus V to minus V. But again 0 it is there, so it is going to make a transition from minus V to plus V volt, and from plus V volt to minus volt, again transition as bit 0 it is there. After that bit 1 it is there, so no transition, and again there is a bit 1, there is no transition it is there. So hope so you understood both Manchester and differential Manchester. Now the Manchester scheme, it overcomes several problems associated with NRZL, and differential Manchester it is going to overcome several problems associated with NRZI, as there is a no baseline wandering and no DC component, and because each bit it has a positive and negative voltage contribution. Only limitation is that minimum bandwidth for Manchester and differential Manchester is twice that of NRZ. Now moving towards the third type of category of line codes, that is called a bipolar scheme. Now in this scheme there are three voltage level: positive, negative and 0. The voltage level for one data element is at 0, and while the voltage level for another element, it alternates between positive and negative. So the first type of is that what? AMI, that is alternate mark inversion. A neutral voltage C, it is represented by binary 0 and binary 1 are represented by alternating positive and negative voltage. So you can see on the screen that bit 0 is represented by what? 0 voltage. So you can see on the screen that 0 is represented by 0 voltage. First binary 1 is represented by positive volt. Since next bit is 0, it is represented by 0 volt. But now next bit it is over here 1. So binary 1s are represented by alternating positive and negative voltage. So earlier it was positive, then for next bit 1 it would be negative. Again binary 0 it is there, so 0 voltage. Next bit it is 1. So earlier it was negative, so alternatively it would be what? Positive voltage it is here. Again next bit it is a 1, so it is represented by negative voltage because previous voltage was positive. 0 voltage is represented by 0 voltage, and since next bit it is 1, so earlier it was represented by negative voltage, so this bit it is going to be represented by what? Positive voltage. So hope you understood what alternate mark inversion. In this name itself, inversion, we have to do the inversion. Alternate in the sense what? That it is binary 1, it is represented by alternating positive and negative voltage. Now, the next type of bipolar scheme, it is called a pseudo-ternary. In pseudo-ternary, basically, bit 1 is encoded as 0 voltage and the 0 bit is encoded as alternating positive and negative voltage, exactly opposite to the AMI. So how is it? So if bit 0 it is there, then there is a alternating positive and negative voltage it is there. But if bit 1 it is there, then there is defined the encoded as 0 voltage. So see over here, since it is a pseudo-ternary, then what is going to be happen? That bit 0 is represented by plus V volt. And since next bit it is a bit 1, it is encoded as 0 voltage. Next bit it is a 0. Now earlier 0 bit it is defined by encoded by this plus V volt, then definitely the next bit 0 is represented by minus V volt. And after that again bit 0 it is there. Since we have to represent this 0 binary 0 by alternating positive and negative voltages, so earlier it was negative, now for next bit 0 it is represented by positive voltage. Next bit it is 1, so it is 0 voltage, 0 voltage. Since next bit it is a 0, earlier we use a positive, so since it is an alternative to it, so it would be negative. After that again bit 0, it is be positive, and next bit it is 0, so it should be negative, and last two bits are 1, so there is a 0 voltage it is there. So hope so you also understood this AMI and pseudo-ternary which comes under this bipolar scheme. This bipolar scheme is an alternative to NRZ, and this scheme has the same signaling rate as NRZ, but there is no DC component as one bit is represented by voltage 0 and other alternates every time. Here it is the overall chart, it has been given to you. So you can see on this screen that how the NRZL, how NRZM, how NRZS it is going to take place. What about RZ, biphase? So what we have seen, it is just a summary of that chart. Now, and this is the overall line diagrams are there. So this is the data it has been given. You can see what we have studied up till now. So it is represented in this common screen, that is NRZL, how it would be NRZM, NRZS, RZ, biphase, LM, is differential Manchester, all the things. So moving to the performance comparison of various line codes, it is very important. So it is polar and over it is a bipolar. So you can see the transmission of a DC component. It is present in polar schemes, polar RZ as well as polar NRZ. Similarly, in AMI and Manchester, it is not possible. In polar quaternary, basically it is not in your syllabus. So it is possible over here. This is the signaling rate it has been given to it. Noise immunity. See the noise immunity, it is very low for this polar scheme and high for bipolar scheme. Synchronizing capability is also very good for bipolar schemes and poor for this one. Bandwidth requirement, it is 1 upon T, 1 upon 2T. Similarly, same for here, and for Manchester it is a 1 upon T. What about a crosstalk? There is a huge chances of crosstalk in polar schemes, and it is very low in your bipolar schemes, that is AMI and Manchester scheme. Now, so we have up till now what we have seen, that what are line codes are there. Line codes, basically it is what digital to digital conversion it is there. And why line codes? Why we are converting it? Then we have seen the different types of the line codes, and we have seen the each type, that how we are going to make the waveform. If in your examination it has been asked that draw the NRZ, draw the polar NRZ, polar RZ, bipolar. So hope so you understood it, that how to draw it. Just there is a small correction. In previous lecture I have given you assignment number 5. Here are some modifications in that one. So please refer this assignment of our previous lecture. So please note it down. And for today's lecture there is a assignment number 6. You have to note down this assignment. You have to write the answers and submit to me. So any questions or any feedback it is there, you can post it to on my email, which is shown on this screen, and it's all about our today's lecture. Thank you very much.